Hi, so today we are going to solve the first two questions of biweekly contest 148. Okay, first question, which is number 3423, and the title is maximum difference between adjacent elements in a circular array. We are given a circular array and we need to find the difference between the adjacent elements. Okay, since let's take an example 1, 2, 4. Let's write it down 1, 2, 4. The difference between these two elements is 1, difference between these two elements is 2, and the difference between these two elements is 3, since it is a circular array. So maximum of this is 3. Similarly, for next test case we would get a 5, since the difference between first two elements is 5 and the next two elements is 5, and the first and third elements is also is 0. Maximum of them is 5. So answer is 5. What we simply do here is, let's skip to the code part. We just define a variable named n, which is the size of array. We for now define our answer as int minimum, which is the minimum integer of possible in integer. Now what we do is run a loop from first index to last index in forward direction, and what we do is we just get the difference between absolute difference, not only difference, since we are asked to do a absolute difference. We get an absolute difference between adjacent elements, and from first to last we find it. In the next step we also find a difference between first and the last element. So after this we just return our result. So by this we get our maximum difference between adjacent elements of our given circular array. So this is the code part. uh, so let us go to the next question. Okay, next question numbered is 323424 from Leetcode, which is minimum cost to make arrays identical. So okay, fine, we are given two arrays which are -795 and 72 minus 5, and we are also given a k. Okay, so what we are asked as, we can we should make ARR equal to BRR. For that we can perform the following operations, which are we can split array into any contiguous subarrays in any order. This would cost us k, and we can convert any element of array to other element. This would cost an x. Suppose we are having an element 9 and we want to make it 7. We need to subtract 2, so it would cost us a cost of 2. That is what written here. Yeah, let's skip to a test case, we would understand it better. Okay, now suppose, let us take this example. What is my approach to solve this question is, suppose we are having three elements, -7, 9 and 5, and the other element is 7, -2 and -5. 7, -2 and -5, that's fine. Okay, so my approach here is, so now we are having two options, right? Option 1 is, from the first element to last element, we we don't require any shift. We just subtract the difference between these two elements of the respective arrays. Okay, so in this case this would cost us, we need -7 to be 7. For this we need to add a cost of 14. So option 1, first element, it would take 14 by performing operation 2. For this element it would take a cost of 11, and for this element it would take a cost of 0, since 5 is equal to 5. This would probably be 25. Yeah, 14 plus 11 is 25. Or We also have a option 2. What is that option 2? Let us take a new page. Yeah, 7, 9, 5. 7 minus 2 and 5. What we simply do is we sort both the arrays ARR and BRR. We just sort these arrays. Let us sort them. The first element is 5, the next element is 9, and the next element is 7, the next element is 9. In the next case we have a element of minus 2, and next we have 5, we have 7. This would take a cost of k since we are performing first operation. Since 7, 9, 5 are also the contiguous arrays of the array ARR. So we just sort them. This would just cost us k. Now what we do is, suppose we are given, now we can perform operation 2 on each step. To convert 5 to minus 2, we would require a cost of 7. To convert 7 to 5, we would require a cost of 2. And to convert 9 to 7, we would require a cost of 2. So what the total comes is 7 plus 2 plus 2, which is 11. This is costing us 11 rupees and 11, and the first it cost to perform operation 1, it cost 2. So final cost here is 2 plus 11, which is 13. Yeah. So this is the approach to solve this question. Let's skip to the code part. See, we just took an answer, and we know first let us take the option 1 which we just discussed. We just simply do the difference between, we simply apply operation 2 on each element, and we keep it as option 1. Now what we do is we are performing operation 2. Since we sorted these arrays, this would cost us an cost of k since we are performing an operation 1. Now what we do is we perform on operation 2 on each element of ARR. So this would add up in option 2, and out of these two, since we are asked to return the minimum, we return the minimum of both the options. So this is the code of this question.